Okay, good afternoon and welcome. My name is Dharma Rajan. I worked in VMware for the last 8 years, been a space scientist, then into virtualization. Okay. So the topic I'm talking to is what is the next thing that is coming? So I'm part of the VMware Telco group. What we do is we virtualize your entire telephone call end to end. That's what we have been doing for the last 4 years across the world. And today we have 1.2 billion subscribers. You don't know your telephone call is actually going through a virtual infrastructure platform. So what I'm going to be talking to is what is coming in the future, sort of how LEO satellites can have the ability for you to connect directly to your smartphone, and how the VMware virtualization stack can help build that. Okay, let's get started. Now, this is a standard disclaimer. Should have all read it 10 times. Okay, let's skip that. Now, let's go. So, the topic is going to be pretty simple. First, let us just define what is GEO, LEO, just so you get the bearings on this baseline. Then we'll get to what is a low. GEO stands for geosynchronous Earth orbiting satellites, from which we get our daily TV broadcasts, weather channels, and all of it for a couple of years we've been doing. LEO is low Earth orbiting satellites, which is coming new. Then we'll talk more about LEO satellites, how from a cloud-based solution, network architecture point of view, how it is being built. Finally, we'll talk about the VMware technology that enables to building those things. Okay. Now, very fast, if you look at the globe, only 20% is using the terrestrial network. What happens if you are in the center of an ocean? What happens if you are in a desert? What happens if you are in a remote area where there is no cellular network? What is the way around? The LEO satellite technology is one of the path forward for it. I'll show you how that is happening. Okay. Before we get into the distinction, let me just give you some baselines on this ecosystem. A GEO satellite is typically deployed around 35,000 kilometers above the Earth, so that the Earth rotation and the satellite rotation in sync is always stationary. That's a feeling you get. Then these satellites are heavy. They are about 5,000 to 6,000 kgs in weight, and they are fixed relative to the Earth, and they have a very large lifespan. And today, if you look at the whole space, there are only about 1,500 of these satellites, every country using it for different purpose. And cost is at least 500 million per satellite. Now, start to compare that. What is happening with the low Earth orbiting? When I say low Earth orbiting, instead of 35,000 kilometers, these satellites get deployed anywhere between 160 to 2,000 kilometers, much closer to the Earth. Translate that to technology, very low latency. I'm going to relate this LEO satellite to 5G networks and say how the solution is. Okay? Then from a weight perspective, just around 150 to 600 kgs, low Earth orbiting, these satellites keep rotating. Every 2 hours, they circle the globe in one way. And their lifespan is small, just 5 to 7 years. And these satellites, you cannot just do an upgrade, right? It's sort of a rip and replace. You bring the satellite down and then you put a new satellite up. And today, what is expected is about 50,000 such satellites are expected to go into the space in the next 4 to 5 years. So that is the volume, and the cost is also pretty less. So this is some basic thing. Now let us get some technical aspects of this. Use cases wise, how do you get a direct connectivity from the satellite to your smartphone? And the other area, big area, is backlog. What happens if a 5G network is not available for some period of time? What is a back-end network? How do we have connectivity, continuous connectivity? Those are the things that LEO satellites can bring. Latency point of view, the reason we have put the 30 milliseconds is 5G network is supposed to provide you that low latency connectivity for satellites. Then speed. Starlinks have already tested up to 90 megabits per second. I'll show you who are the players here and how they are getting it here. Now, how do I relate this to 5G? If you take a satellite band, they operate in all these bands, L band, C band, KU band, KA band, all these bands, very strict spectrum frequency ranges. But what they don't have is, there is no capability to share spectrum across satellites. Now, let us take LEO satellites. they start to operate in the L band, Ka band and the V band. Now we start to look, they have smaller bands, and these frequency ranges are such that because they are close to there, they are just about 50 times faster. Now start to compare that with 5G networks. 5G as per 3GPP standards have defined true frequency ranges for 5G. That is either in the 400 megahertz to 660 gigahertz and then the 24 to 50. Now, if you look at L band, the L band can map within the FR1 band of 5G. So that is why you are able to get from the satellite directly to your phone. That is one. The second, the Ka band, if you look at the higher end of the Ka band and the lower end of the V band, they fit into the FR2 category. So there is an ability, and the other clear thing that 5G provides is the ability to do spectrum sharing. So with that capability, because everything is in software, the key thing about 5G is the radio access network, which is all very proprietary hardware based, is now transformed into a complete software based solution. And that is what VMware provides on its platform. And you saw yesterday in the session, dish networks they announced, right? Everything there, the control access network is all software based, running on the VMware. So I'm going to talk about how that platform relates to this. Okay? Now, quickly, if you take today what is happening? Iridium is a company which has already launched about 77 satellites. All of you are using for your GPS, that's how you get it. And 77 stands for the atomic number of the Iridium this time. So these are operating at 780 kilometers. Now, if you look at these satellites, they spin around like this. And today the federal government is using this for every purpose, war zone, all of this we use quite extensively. Now, each satellite, because they are spinning, they need to have crosslinks. So what happens when one satellite moves away from this location? So there are crosslinks, so they form a sort of a mesh there, and they are also rotating. Because of the rotating at the very lows from the earth, there is a drag, and the drag means there is a force, so we need to obstacle that force there. Now, and the ground station, which makes all this management of it, becomes pretty complex. So how do you take all of this into account and design the architecture? Once we look at it, okay, what is happening in the industry? You are already seeing that there are a lot of players in the field emerging. Very recently, T-Mobile and SpaceX communication announced that they are going to extend the cellular network with 5G across air, space and sea, and with using the small cell technology. That is where 5G spectrum, all those come into play. The other key use case is many companies are working on is how do I provide a backup in the event of any network, cellular network failure, and make sure that in the event of earthquake or disaster, this LEO satellite network will supplement it. Third, think about aircraft. When you are flying today, if I fly American, probably they give me 20 minutes of free time via SAT, But think about getting that free for your entire trip without any interpretation. So you have a terrestrial network, the ground network, which is providing today's coverage. This LEO satellite, which is a non-terrestrial network, extending that coverage for you. So think of it when you for your air flight connectivity. Then very secure network, like the Department of Defense, those types of networks will have a lot of use as part of this technology. Okay? So this is some of the baselines. Now, who is there? Who are the players here? You see, 50,000 satellites I said. See, SpaceX alone has already deployed 775 Starlink satellites, and they plan to deploy 42,000. Now, as you move, OneWeb, they have created their entire satellite cloud infrastructure. It's completely virtualized infrastructure base on which they are running. Their target is to around 2,800, and they also have launch programs with ISRO in India, and they start to plan deployment in large scope. Amazon just 83 satellites, but if you think about it, it will not even be sufficient for their own supply chain. So the growth is very large as you go forward. Inmarsat, a very well-known satellite provider around the globe, and they are starting out what is called the LEO birds. They call it. Now, as you see the bottom, there are many more. Around the globe, there is a phenomenon now that low Earth orbiting satellites are going to create a differentiation in the world. So there is a lot of investment that is happening. So, with that as the baseline, what do I see as a four interlocking trends that is happening in the industry? The first trend I see is now 5G new radio networks are being built entirely in software. That is the first thing. And these networks, evolution of the edge, you have seen in many sessions, right? The enterprise edge. Similarly, telco edges are becoming very prominent. Private 5G is becoming very prominent. And they are all built in a cloud native architecture. So, what this architecture enables you is terrestrial networks that are existing today, cell phone networks, and the non-terrestrial networks, the satellite-based network, they all can start to communicate. I'll show you in a minute. And they use cloud. So, cloud native architecture. Second, if you look at the industry, the couple of industries, so Ericsson, Qualcomm, Tails is one of the biggest satellite operator of NATO, right? So they are all combining, forcing hands and building relationship right from the OEM vendor to the service provider to the satellite provider. And similarly, Nokia with Vodafone with AST. AST Mobile is experimenting a lot of direct connectivity from the satellite to your smartphone. How do you bring that? Okay. Then Telstra, AT&T and OneWeb, complete cloud native type architecture. Reliance Jio in India with Luxembourg ACS. So big companies are investing a lot. That is one trend. The third trend is on the standards. All of this will not be possible unless regulatory and standard bodies across the globe they start to unite. 3GPP standards from release 17 have started to include terrestrial network satellites into the specifications. So that is gaining a lot of importance there. Department of Defense, today it's all a complete 3G network with heavy dependency on satellites. When they move to 5G networks with a LEO satellite, this brings them a lot of very secure way of doing things. Then regulatory policy across the globe, because when you say space and we are launching satellites and it's moving around, you cannot say regulatory for Americas, regulatory for EA. It's a global regulatory policies are being built. The FCC has announced its support for what is in service, in space. I can do service, maintenance, operation, management of satellites. So these are types of things that are evolving. So under this, if I have to manage all these satellites, how do I manage it from the ground? SaaS-based models are becoming more relevant. So if I just take a ground station as a service, is becoming very relevant. Just to give you some examples here, Leave Space along with Google Cloud is one example here. Microsoft as Microsoft Orbital is another example of ground station as service. AWS, where VMware comes, multi-cloud. So we can support across any of these clouds in a LEO satellite configuration for any ground base as a service. Okay. Now, this is the high level of the where the LEO satellite technology. Let us get into the architecture a bit, of how this is all happening and how you can build this network. I talked to you about the edge, right? You have things like connected cars, you have drones, you have airplanes, you have a 5G network with all your cell phones and all of it. Now, at the edge of the network today, we are able to build radio access networks completely in software on any COTS platform. That's what we have. That is called the VMware RAN technology, which was introduced. We are in release 2.0 of that. We will have many sessions on telco, on radio RAN, access network is there at VMware. Now, consider there, you divide a radio network into a control plane unit and a data unit. Now, same thing you can do with satellite and put that in the same edge. So when you get the spectrum connectivity, you can transfer that connectivity from a LEO satellite into a traditional network of a 5G, so that it can connect to a terrestrial network, a non-terrestrial network to a terrestrial network. That continuity you can maintain, thereby you can provide that seamless connectivity. Then you can connect to your 5G core cloud, either through a service provider or you can connect to a multi-cloud, where a part of it is managed by public cloud provider, part of it by VMware. The management part of it, you can now start to think about how can I have a combined operation center both for terrestrial network and non-terrestrial network. Okay. So there is a lot of cost savings. Let us dig a bit deeper into the edge. I talked about the terrestrial network, the radio network where you have the control unit, data unit, and also what is called the RAN intelligent controller. How intelligently you can build applications all in software, and you can manage it through open specification. ORAN is an open specification that is today available for radio access network. So once you have these types of open specification, you can also extend that to the non-terrestrial network. So in the same edge and core, you can start to build control units and data units very specific for satellite application and radio application. Now let us look a bit into what are the details of those radio applications that you build for a satellite. Think of it as a control plane and a data plane. Just so, if you take the physical layer, couple of layers can be control plane, couple of layers into the data plane area, and then you start to think about all of this in software, the protocol stack being written in software, the satellite payload, satellite crosslinks that we talked about. Then we also talked about these satellites are there for some period of time, and then they have to, after their lifespan, they have to be deorbited, slowly brought down, and then from there the drag has to be managed from the low end. All these are software applications that you can run. Now the other key thing is we talked about dynamic spectrum sharing. So that is again in applications. Then when you talk about satellites, you cannot forget about jamming. So because anybody, the recent war, you know that Starlink was able to completely remove the jam. So these are things in software you can do much faster. Then encryption, security, encryption. So the thing is, all of this can be built on a commercial off-the-shelf hardware using the VMware technology, so such that all these are applications. And the beauty of this platform that we have is you can bring it from these applications from multiple vendors of your choice, the freedom of choice that we give, and then integrate it because they have open APIs and SDKs, so anybody can build to these platforms. How do they do this? Let me quickly run through that. Okay. This is, if you start to look at the whole picture of the terrestrial network and non-terrestrial network, these are all the types of use cases that you can give. And the type of edges that you are going to start seeing is the far edge, near edge, and the nomadic edge. Think of nomadic edge as a mobile edge. Like in a war zone, probably you have the war units going in, and so you can have, the soldiers have applications that they can know about as the edges move, because they have continuous connectivity. One more beauty here is not only the satellite gets connected to the edge, on the other hand, because the satellites are quite far high, the angle of connectivity is large, they can even directly talk to the core of the network. Thereby your cellular communication can become much faster. It doesn't have to really go through an edge. So these are all the different types of edges and core networks that you can use for building a LEO constellation. Okay. Now let me talk now about what is the VMware technology in building it. I told you about the radio access network, and so here is a stack. The stack that we use is, on the bottom of it is a real-time operating system called Photon OS. Today VMware ESXi can support real-time OS, and this real-time is needed in order to for that reduced latency that you need for radio application, millisecond level latency, very high throughput, all of that. So that is, so on top of it, the standard Tanzu for Kubernetes. So everything, because when you think about 50,000 satellites and each satellite having 20 different applications and 10 containers, it easily boils down to millions of containers within that. So how do you build that to scale, and how do you automate all of this? This is called a telco cloud automation layer which is built. I'll get to that in a minute. And so on one side you can have the radio network control plane, user plane, and the other side you can also have satellite, LEO satellite application, and these are all on a common infrastructure. You can have logically, securely demarcated from top to bottom, right from your CPU, memory, network IO, all of that you can securely demarcate them, so that when a problem occurs, you know from where that problem is. Okay? So with that baseline, we also talked about how do you connect. I said open standard APIs and all of it. This is the RAN intelligent controller. We have two controllers there. One is called the distributed RAN intelligent controller and the other is called the centralized RAN intelligent controller. The distributed RAN intelligent controller is used in order to build those applications that you start to support in the near edge and far edge on the control plane side of things. The centralized REC is used for more of the management, operations and management layer of things. Now, where these can be located, both the centralized distributed REC can be located in the far edge, cell site or in a satellite hub. You can locate the centralized REC either in the edge or an aggregated site or on the NOC site. So, at a higher level you can even locate it. So, this is the, and since all this is open interface and published interfaces and you have APIs and SDKs, you can build applications that LEO satellites may need. So, this is the architecture, a common architecture that you can build your radio network as well as the LEO satellite networks. Okay. With that, so that is one part on the edge. Let us talk a bit about the core. So, if you look at the core, VMware has what is called the Telco cloud platform, where we provide a secure way for you can build a different types of control plane and securely segment any vendor. Like for example, you may have on the core, you may have an IMS network or a Vault packet core. You may bring in 5G networks, 5G network elements, or AMF, SMF, UDR, UPF. All of these functions can be securely demarcated in a control plane. There are different options. VMware started out what is called the vCloud Director, the very secure way of segmenting, logically segmenting. On that stack, that is the control plane. Then if you want to use OpenStack, you can also use that. That's also provided. Then the third, if you're just using a virtual network function and just want to continue on a vSphere stack, even that is with vSphere and vCenter, that is also supported. And you want to add on Kubernetes into that stack control plane, that is also supported. The fourth, which is what we see, is going to be the evolution where you have a complete Kubernetes control plane and everything comes on containers. Now, the advantage of this whole control plane is whichever control plane mechanism you choose, you can connect to a public cloud. Whichever type of public cloud you want, you can connect it, orchestrate it and automate it. So, orchestrate and automate it across multiple clouds. So, you can orchestrate it to your public cloud. You can orchestrate and say, I need this satellite virtual network function, container network function to be placed in a Microsoft Azure cloud. I need it to be placed in an Amazon cloud. You could do that and orchestrate it completely. And the future, there's also capabilities to do network slicing. So, you could do a slice and say that this slice is to just manage my terrestrial network. I have other slice with a different set of SLAs that would be managed for my LEO network. So, you could segment it like that. You could segment it as part of based on your different security policy. So, that is the flexibility that this platform gives. The other thing is all this is based on open standards. So, thereby you can bring in any vendor of your choice. For example, the core network, you may bring in a part of your 5G network may come from Nokia, comes from Ericsson, some may come from Microsoft Affirm. For us, we are agnostic. And that agnosticity is what helps you to give you that freedom of choice in building this network. Okay? I'll step into two more quick things here. One is basically automation layer, the complete automation stack. This is called the VMware automation stack. As you can see here, the functionality is available at different layers of the stack. I don't think I'll have time, but there are very specific sessions on this very topic here at VMworld. So, take a look at that if you want to get more details. This is one part of automation. The last part I will say is about operations. Okay, I have built the infrastructure, I have automated it. Now, every day I have to manage it. How do I manage it, right? Operations become very, very critical. So, you need a multi-cloud operating system, and that is what we call service assurance layer. And this is another product of VMware. I don't think I have enough of time to get into the depth of it, but again, there are multiple sessions at VMware Explore, so you can connect and listen to that. With that, I think I'm done and I'm going to ask you any questions you have. Please take the survey and thank you. Any questions?